Morning, y'all. Let me see if my slides show up now. How's everyone's morning going? All popped up? Well, hopefully this will be a fun talk. This talk is a little bit about the concept of breaking things on purpose, which is not necessarily always the thing that people want to hear, especially when you're in a field that you're trying to build things that are more resilient, try to keep your company up and running, automate stuff. When you hear the part that you want to break things, it's like, well, I work so hard to make this, like, for me not to break it myself, why would I want someone to go ahead and break it? But hopefully, you'll learn something new today, and it'll be interesting. My name is Medina. I'm currently working as a chaos engineer at a small startup called Gremlin. We do resiliency software. Right now, we've been focusing on chaos engineering software. Previous to that, I was at Uber for about 2 years, where I worked as a software engineer, as a site reliability engineer, and I worked on some really cool stuff there. I got a chance to completely come on board to the chaos engineering project there, and that was a fun space because Uber was running bare metal, and they wanted to use the big open source tool called Chaos Monkey for chaos engineering, but because it was running bare metal, they couldn't use it. It was only done, like the open source tool was meant just for using AWS, so they went ahead and built their own stuff. After that project, I moved over to another crazy project, which was trying to move Uber from a bare metal data center to the cloud. And basically, the idea was the last data center that Uber built actually took 6 months. And upper management was like, hey, why don't you go from 6 months to 24 hours? And you do that by just using the cloud. And it's like, all right, cool. Well, we want to be vendor agnostic. So we had to build this abstraction layer using GCP and AWS and try to get that up and running. I ended up switching teams before we got to see the end of that. I recently talked to a manager at Uber, and they're still trying to move Uber to the cloud. It was like, in general, very heavy in legacy stuff. When I joined, there was around 1,000 microservices, and about now, they're looking at 3,000 microservices. So just in 3 years, they built 2,000 microservices, which is insane. But it's part that comes when you're a hyperscale growth startup. Apart from that, I've worked at a credit union in South Florida, at Google, Quicken Loans, and I've done college research with Stanford University and Miami-Dade College. I'm also a proud college dropout. I'm a self-taught engineer. I really believe in learning, but for me, being in the education system, that necessarily wasn't the best place for me. I didn't find an inclusive space where I can fit in, and at the same time, I had a better time teaching myself how to build stuff versus listening into a lecture and learning that way. You can find me on Twitter. There, I'm usually raging about mental health, diversity, and inclusion, or just in general some cool engineering stuff. So, with a raise of hands, how many of you in here have heard of chaos engineering? Okay, cool. And with another raise of hands, how many of you have actually run a chaos engineering experiment? Okay, some few hands. So, hopefully, by the end of this talk, you can ping me on Slack or on Twitter and be like, hey, your talk was cool, I learned something, and I ran my first chaos engineering experiment. Because there's actually many ways that you can do these experiments, and we're trying to make it a lot easier for people to have fun doing this. So let's start off with, what is chaos engineering? Chaos engineering is thoughtful, planned experiments designed to reveal the weakness in our systems. No? OK. All right, I'm breaking things, apparently. So the CEO at the company I work for, Gremlin, has come up with this really cool analogy when it comes to explaining chaos engineering. Chaos engineering is like a vaccine, where you inject some harm in order to build immunity. So why do you want to do something like this? Why do you want to inject failure? Why do you want to inject harm? Why do you want to break things? Well, as most of us in this room know, we have seen our companies just continue scaling. We're getting more customers. And for those that sit in the back, we have learned that we need to keep those companies up and running. We have seen our infrastructure just grow exponentially. And for some of us, we've actually gone from monolith architecture moving over to microservices. As we've been doing this, we've just been building complexity over and over on top of one another to the point that it's kind of hard to be able to know how things are running, what some microservices even do if the company has such a large base of microservices. Some of us have also been on call and have learned the pains of being on call, and it's not necessarily a very fun experience. You can also get like pager fatigue, and you can actually burnt out. That's actually what happened to me. I burnt out of Uber, and I decided to leave infrastructure. And I was like, I can't do this. Like, just the culture of it, it was in general very hard, and the on-call life, when it's not set up with good practices of on-call, you're bound to get burnt out. So chaos engineering also kind of like helps you think about those things. You want to not burn out in your engineers. You don't want them to get paged at 3 in the morning just because you set up the wrong threshold or just an alert that doesn't necessarily need to even get triaged at that moment. And with that comes the fact that downtime is expensive. There's a report out there that shows that a company loses about $300,000 an hour just by having an outage. And that's just 1 hour. And this all depends on what type of services you're providing to your users, to your customers. So, for example, if you're a company that's running a sale and you only have the sale up for like 12, 24 hours, if you're down for 3 of those hours, well, you're looking at probably more than those $300,000 that hour. At the same time, we always want to provide our customers a really good experience. And we can't always necessarily do that. We have dependencies that are failing on us very often. And it's not necessarily very easy to be like, when a customer comes to you and is like, well, I can't use your page because like this is not loading up, or in general, like I can't process my card payment and things like that. You can't be like, oh, sorry, it's not my fault, it's that company's fault. Because for them, they don't care what other companies you're using. They pay you, they trust you, and they want you to provide a very good experience, and you're not doing so in that moment. So with chaos engineering, there's a few ways that you can actually try to help those situations, make them a little bit better. One of the main ones I like talking about that you can use chaos engineering is outage reproduction. So I mentioned that dependencies will fail. So here are 2 screenshots of outages that maybe most of you in this room have heard. Maybe some of you were on call. The huge S3 outage and getting the DDoS attack for the DNS service. And these are like some of our favorite websites went down, and it was like, well, what do I do with my time? I'm bored at work. I can't go on my favorite page. So it affected many, many people. And with the fact that you have outages like this out in the public, we've been creating a better culture of sharing failures. And now you're able to look at those big outages that companies have had, and it's like, okay, I have a dependency on that company. What happens if that was to go down? How can I continue providing a good experience? So for S3s, maybe like actually running on 2 different regions. For a DNS, is actually having a secondary provider for DNS in case something actually happens to your primary. So you don't necessarily come to that realization unless you actually dealt with an outage like this. You had a buddy that told you, hey, I had this outage, and we're building this to make it more resilient. And maybe you get the idea that you now also want to implement a secondary DNS provider. Another of my favorite ones to talk about is on-call training. Onboarding to on-call is not easy. You probably just got thrown a pager, and it's like, you're on call. And if you didn't do that, well, you might be lucky, because that was my experience. I actually joined Uber as an intern, and I was on call on my 2nd week. And it was just like, here's your PagerDuty account, here's some runbooks, and you're on call for this chaos engineering production stuff. I kind of forgot to mention that I actually never took a systems class. I never took any infrastructure stuff. So this actually was the first time I was dealing with systems and even production to begin with. So it was pretty crazy. So when I get that page at like 4 in the morning, like 4 days into my rotation, it was like, all right, cool. I get to open up this runbook. I can like look at the dashboards, see what's going on, hopefully triage this incident so it doesn't continue growing. But when I look at the things that the runbook says to do, first of all, the runbook is 180 days outdated. So I'm like, all right, crap, I'm an intern. Do I just execute this command and hope that I'm not fired tomorrow morning? Like, is that how it works? Like, crap. So looking at that experience, I like think about it now, and I'm like, you know what? You know what would have been a really cool way to onboard to on-call? Well, if we would have done a chaos engineering experiment, and I would have sat in with the other engineers and would have actually been able to reproduce an outage that has happened, and I'm able to know where to go, what to look for, and still have that feeling that I'm in an outage mindset, but not necessarily knowing that I'm affecting production. And I think I forgot to mention that for the outage reproduction, this is also something you can do with previous postmortems you have done in your company. You kind of like do all this like writing of like what went wrong, and you come up with these really awesome ideas on how to not let that happen again. And you come up with a plan that, hey, I'm going to do this in the next quarter. But there's really no other meeting that most companies have set up that is like, let's go back and check if we actually fixed all those things that caused this outage. So with chaos engineering, you can actually do just that. You can go open up that postmortem, see the things you wanted to fix, build experiments on the things that went wrong, and run the experiments to see if the outage, like the scenario that caused the outage would happen again if you're actually safe. Some other ways that you can also do it is strengthen your products. You can do something like come together as a company and just run a whole bunch of chaos engineering for any new feature, any new launch that you're doing for your company. Battle testing new infrastructure and services is one that I talked about at a chaos engineering conference in San Francisco about 3 weeks ago. And that one was basically the concept of we have all these cool technologies coming out, but it's kind of like hard to choose sometimes if you're not like sold on one cloud provider what you want to do. So we actually put EKS and GK, I can't think of the name right now. The Google GKE? Yeah, GKE. We put those to the test. So we loaded up containers with the Kubernetes dashboard, and we ran chaos engineering experiments on those. And we were basically, OK, what happens if we shut down this dashboard container? Well, usually Kubernetes, reliability. Another one will pop back up. And that necessarily wasn't the case. So if you're interested in that, you can ping me, and I'll send you the link for the rest of those videos. But before you think about doing chaos engineering, there's a few things that you actually need to have in place in your infrastructure before taking the steps to doing so. The number one and the most important one is that you need to have monitoring and observability in place. You need to know how your systems are doing currently, and you also want to know how your systems are doing as you run these experiments. Having on-call and incident management is the second thing that we recommend. In general, it's really good like site reliability engineering practice to have something like this, but at the same time, you're able to think about how your company deals with outages, what are the services that are most critical to you, and what happens when those go down. Do you have like a Sev 0, a Sev 1? And in general, you come up with better plans for that. You also want to know the cost of downtime per hour for your company. This, in general, is a really good practice when you're trying to pitch chaos engineering to your upper management. You want to let them know, well, we're losing this amount of money in outages, and if we do chaos engineering, we can actually try to save some of that money. And if you actually are able to run these experiments and build a more resilient system, when it comes times for performance reviews and things like that, you can also think about using the cost of downtime per hour into that write-up. But It's very important to know that chaos engineering is not about breaking production just for the hell of it. It's not about creating outages. It's not about running chaos engineering experiments and not letting your team know that you're running them, or just doing them without even having monitoring in place, or in an unsupervised way of like, I'm going to go run all these experiments and I'm going to go have a beer with my buddies. That's not necessarily how it works. You want to make sure that you're running these experiments and you're looking at those boards, or you have made sure that your alerts for those dashboards are actually sending alerts. So at that chaos engineering conference I talked about, we also had Charity Mayers, the CEO of Honeycomb, give a talk. And she gave this really awesome talk called Chaos Engineering Without Observability is Just Chaos. So when you have chaos, you might just feel like Elmo. And that's not necessarily what chaos engineering is about. That's the reason you want to have monitoring and observability in place. Don't feel like Elmo. The cool thing with chaos engineering is that you can and you should actually inject it in every single layer of your stack. So you can go to the bare metal, you can go to the cloud infrastructure and run chaos engineering experiments. But you can also do that like in your databases, in any set of like data store, messaging streaming that you have, any caching, the application, the UI, and of course like the API. So pretty much anywhere that you have code or infrastructure in, chaos engineering can be implemented there. At Gremlin, we have been working with companies, trying to onboard them to using chaos engineering. And we have heard some other pain points, and most companies are focusing on these 5 technologies to inject some chaos into. So that includes like Cassandra, Kubernetes, Amazon ECS, Elasticsearch, and Kafka. And with these, you also start thinking about what dependencies they have too, and how do you run chaos engineering experiments on those things. So for like Kafka, I've been messing around with that like the last month. And you can also do chaos engineering experiments with like Zookeeper, and it's not necessarily all just about Kafka. So how do you get started with chaos engineering? Well, you don't necessarily want to start with the low-hanging fruit that you have in your infrastructure. You actually want to go ahead and choose those top 5 critical systems that you have there. After you choose those systems, you want to go ahead and whiteboard it. And this is where you're actually able to see, like, what dependencies do I have? That could be in internal services. That can be on vendors. And after you come up with some of like the idea of the architecture of it, you want to determine what experiment you want to run. And this all depends on what you're trying to, what's the goal of this chaos engineering experiment? Are you trying to reproduce an outage and you have very set things on like, these are the experiments that I want to run? So for example, like on the resource layer, you can maximize some resources. And that includes like maximizing like disk, CPU, IO, memory, some things that like just happens on like a normal basis. On the state layer, that might be like just killing some processes, killing some containers, shutting down hosts and not booting them back up, or even to the point that you alter the clock of the system. And that's something that would have been really cool for like Y2K. On the network layer, there's like other cool chaos engineering experiments you can run, and some of that includes like packet loss, like latency, and just in general, like DNS. And then after you've determined what experiment you want to run and how you want to do it, you want to determine the blast radius. The blast radius is the concept of starting very small with chaos engineering and increasing as you see the experiment succeed. So don't necessarily just go and run chaos engineering in production on 100% of your hosts, 100% of your traffic, because that's just not good chaos engineering practice. It's not good engineering practice, and you're probably going to break things, and not in a good way. So with determining the blast radius, you actually think about it as a scientific experiment, where you now come up with a hypothesis of the chaos engineering experiment you want to run. Then you go ahead and you run this experiment, but you decided to run this experiment on just 1% of the traffic. So for a company like Netflix, that streaming is their thing, you want to maybe think about like what they're going to be looking at is like the streams per second. But what happens if they inject like latency to 2% of that traffic? Are users still going to be hitting like the SLO for their services? So once you run that experiment, you now look at your monitoring and you make sure that things are going well. You kind of come up with your own definition of success and failure. But let's say you see that you're like completely breaching the SLOs that you have for providing these services for your customers. You want to go ahead and stop that chaos engineering experiment immediately. Abort these conditions. And go ahead and fix the things that were broken. And go ahead and run that experiment once again. And as you do this, if you're running successful chaos engineering experiments, you want to go and increase that blast radius. So if you ran it on 2% of traffic, maybe think about going to like 5% and like continue incrementally, safely increasing. So there's a lot of companies doing chaos engineering. I got a chance to get started around 3 years ago, and the practice was still very brand new. Netflix is the company that's known the most for doing chaos engineering, as they were the pioneers in the space for the open source tool of Chaos Monkey. But I actually found out because I joined Gremlin that Amazon was doing this way before Netflix. They just actually couldn't talk about it, which is a pretty cool thing to know. For getting started, there's something called Chaos Days. Has anyone in this room heard of like Hack Days? Yeah? OK. So Chaos Days is kind of like in that same mindset. A day that you dedicate with your entire company to focus on building resilience instead of new products. So Hack Days got started at Yahoo a few years back. And it was a day that the company comes together to build new features. So with Chaos Day, instead, you're going to be thinking about resiliency. And how can you do that together as a company? How do you strengthen your products? The link under here is actually an entire guide on how to run your first Chaos Day. You need about 90 days to run a successful one. So if you actually start planning now, you actually might be able to run it in the first 2 months of the next year. So it's actually really cool. Chaos Day is a day that you want your engineers, you want the folks that you have invited to go in with these questions. What could go wrong? Do we know what will happen if this breaks? You want to have that curiosity to know how resilient your systems are and how can you make them better. You want to do this in a very inclusive way. But you also don't want to have too many cooks in the kitchen. So we think that a good crew for Chaos Day includes like some upper management, a CTO, a VP of engineering. You also might want to get an executive assistant involved so they can actually help you run a successful event. Having an engineering director or manager comes in handy as maybe they've been at a company for long enough or they actually know the architecture of the company in general. Senior engineers are the ones that for the most part have their hands in the ground and could actually take action on this. But at the same time, you don't want to close the door for new grads and interns to come and learn about building resiliency around the company. And at the same time, it's a really great way for them to onboard into the company and be able to learn how the company, the services work, and things like that. So this slide is a lot of like what experiments you can run. And there's a lot of these things like race conditions actually have caused some huge outages around the world. And with chaos engineering, you can replicate that. You can do simple things of like making sure that if you maximize like CPU and disk, your applications actually don't fail. You can also run experiments on unpredictable circumstances. So with this one, I like thinking about like what happens if a natural disaster hits your data center or the region that you're actually running based out of. Can you do a region failover? And can you do that quickly? So with unpredictable circumstances, you're constantly thinking about like, where do I have my infrastructure? Where is my code deployed to? What can I do to make sure that I'm building resiliency around every single corner of this? So what are some ways that you can get started with chaos engineering right now? There is Chaos Monkey, that open source tool by Netflix that is available. This one just shuts down instances randomly. There's Simian Army, which is the upgrade of Chaos Monkey that Netflix put out. And this just includes a few more monkeys and is working with Spinnaker that you're able to do some chaos engineering. Cute Monkey is that same concept of the Chaos Monkey, but just for Kubernetes. You also have Litmus. Litmus tries to make chaos engineering a lot easier to understand in more English terms. Powerful CO is another tool I got to learn about a few weeks ago, put out by Bloomberg. It's Kubernetes chaos engineering. And a lot of these, I'll be posting my slides on Twitter after this talk, so you can get the links there. And I did post a lot of Kubernetes links. That's just because that was the field that I've been kind of working on recently. But you don't need to be running Kubernetes to be doing chaos engineering whatsoever. You can be running this on just your general host level, and there's a few other places to do it. The company I work for does chaos engineering products, so we offer 11 different attacks that you can run just out of the box, and you can do that on hosts and containers. We just yesterday, we put out this really cool guide that talks about Chaos Monkey for engineers. So this is actually a very simple way to get started with chaos engineering after this. If you go over to this link, there's a whole bunch of code tutorials on how to use the Simian Army to deploy on AWS with Spinnaker and run chaos engineering experiments. You can also use Chaos Limas, which is a chaos engineering tool for Bosh. There's another one called Pumbaa that makes it also very easy to run chaos engineering experiments. So there's a few open source tools out there that can get you started. So it's a really cool resource to have in handy. And if you want to learn more, there's this awesome chaos engineering channel that is currently available. It has around 1,800 engineers all over the world. And they've come together and put on these awesome chaos engineering meetups all across the globe. I've gotten a chance to speak in San Francisco, New York, Berlin, and Hamburg, just about chaos engineering this way. So it's a cool way to continue learning about this space. And you can find me on that Slack if you have any questions about chaos engineering too. But that's all I have for y'all today. Thank you very much for coming to my talk. If you have any questions, feel free to drop me an email. You can find me on Twitter, and I'll be around today for the rest of the day if you have any questions. Have a good one.